Hey guys, today we're going to look into the basics of Node and Express.js. In one of my previous videos, we spoke about the basics of web application. In the sense, the web application consists of a web browser, a front-end server, back-end server, and a database. So in this video, we're going to look into the back-end piece. We're going to go into the details of the back-end. A popular choice for backend is Node and Express. So we're going to go into detail on how Node and Express works. So what is Node.js? Node is not a programming language. Node is just a JavaScript runtime which takes in your JavaScript code and converts it to a machine language and runs it on your server. Node uses Google's V8 engine. Google developed V8 engine for the Chrome browser. What the V8 engine does is takes in the JavaScript code and converts it to the machine language to be executed on the client-side computer. The Google's V8 engine is written on C++ and it provides better performance than any other JavaScript engine. So Node is an event-driven, single-threaded, and non-blocking I/O. So what does it mean? So single-threaded meaning the Node.js has a single event loop listening for events, and as soon as it receives an event, it could fire an I/O operation which is non-blocking. I'll go into details in the next slide, but bear with me for a moment. Node.js is best for I/O intensive tasks. So let's say the web application serves a lot of users and it does a lot of I/O with the database, files, network I/O. It's best for that kind of tasks more than like CPU intensive tasks. Node has powerful core modules like FS, HTTP, crypto, so on and so forth. Node uses NPM, which is called Node Package Manager for third-party modules. So the Node Package Manager is the largest package manager, and it contains a ton of modules that you could leverage for your web application. So one of the reasons Node became super popular is because now you could use JavaScript for server-side programming. Usually JavaScript is used on the client side. One of the reasons JavaScript became super popular is because usually JavaScript is used only for the client-side scripting. Now, the same language can be used for back-end programming too. So a full-stack developer who knows JavaScript or a developer who knows JavaScript can use the same language for the front end and the back end. So which is really powerful because he doesn't need to understand two different programming languages. It's just one language used on both the sides. So let's look into the asynchronous programming or the non-blocking I/O. Let's look into the traditional architecture which is synchronous programming or the blocking I/O. So in our example, let's say we have three tasks, which could be just like a database call. So the program requests a database call and then it waits for the data to come back. So the time between the request and the response, the CPU doesn't do anything. It's just sitting idle, and there could be like a millions of CPU cycles wasted. So once the response comes back, it executes the task, whatever it is, and then it moves on to the next task. It sends a request, waits for a response, and then it executes the tasks. So on and so forth for task 3, task 4, task 5. So let's say each I/O task takes like 1 second. For this example, the entire process could consume full 3 seconds. So Node uses asynchronous way or non-blocking I/O mechanism by default. So meaning in this example, Node fires off the I/O task 1 and it doesn't wait for the response to come back. It moves on to I/O task 2. So when it starts, it fires off the I/O task 1. What it does is it notes down the task 1 request has been sent, and then it starts the IO task 2. When it starts the IO task 2, it notes down again that it has started the IO task 2, and then it moves on to the IO task 3. So during this time, when it receives a response for IO task 1, it executes the follow-up code that it has to take care of. So in this way, the non-blocking IO or node doesn't wait for a single task to complete. It can move on to the following tasks, and then when it receives a response, node can take care of the code to execute after it receives the response. Meaning, let's say it has requested some database information, and it moves on to the task 2. And then when it receives the information, it could grab the information and then it sends back to the user. In this way, all 3 tasks in this example are executed in just 1.3 seconds instead of full 3 seconds in the blocking I/O. Millions of CPU cycles are saved, and in this time there could be another hundreds of requests that the program could execute and get the response for the users. So this way is super powerful. That's the reason Node is super fast. It doesn't wait for the I/O to complete to start the next I/O. It moves on to the next task while it notes down the I/O task, and then it executes the code after it receives the response. In this way, it's super efficient. It doesn't block the I/O. It doesn't wait for the task to complete. In this way, it just continues receiving a ton of requests. So to enable the asynchronous and non-blocking I/O, there are 2 important features that we need to discuss about. One is called callbacks. The other one is epoll. So what is a callback? So there are 2 ways of programming. One is synchronous programming. The other one is the asynchronous programming. In synchronous code, the code is written in a linear fashion, meaning we start with an IO task 1, and when the task is complete, do this function, and it goes to IO task 2, and then execute this code. IO task 3, and execute this code. And this code is executed in a linear fashion, and hence synchronous programming. And this is where when the IO task 1 is executed, the system waits until it gets the response and executes this line of code. In asynchronous programming, even though it looks like it's linear, it's not executed in a linear fashion. So what happens here is it starts with the IO task 1, and then it moves on to IO task 2, and then again it moves on to IO task 3. What happens is, let's say while it fires up the IO task 3, let's say the IO task 1 gets a response. Once it gets the response, it executes this callback and runs this code. And then let's say after that, we get the response for the IO task 2, and then it runs this code, and then followed by the IO task 3. So what happens here is the callback is written, but it's not executed in a linear way. Once the IO task 1 is fired up, it moves to the task 2, but only when the operating system receives a signal that the task 1 is completed and has received a response, that's when the callback occurs. And this is the asynchronous programming. It's very efficient. It doesn't wait for the response to come back. It just moves on to the next task, making it super efficient. And this asynchronous feature is enabled by a operating system mechanism called epoll. Let me write that down. It's called epoll, which enables the asynchronous mechanism on Linux machines. In Unix, it's called KQ, and in Windows, it's called IOCP. Since Node is cross-platform, each operating system has this feature to enable the asynchronous mechanism. Moving on to Express. So what is Express? Express is a web application framework for Node.js. Express makes creating API super easy. Express is a third-party module which is downloaded via the Node Package Manager. The Express makes use of the Node Core Module HTTP, and it provides a bunch of functions which makes it super easy to create a CRUD application. Sometimes writing code directly on Node could become a little tricky, and Express makes it super easy to create API endpoints. Okay, let's move on to the next slide. Node Express architecture. So this one is where the user's JavaScript code is written and it's fed to the Node.js runtime. So what's inside the Node.js runtime? It has three important pieces. The first one is the Chrome's V8 engine, which is Google's JavaScript engine used for the Chrome browser. It's written mostly in C++ and a little bit of JavaScript. What it does, it takes our JavaScript code and converts into machine code to be run in the operating system. The second main piece is the Node Core modules. It provides the modules, like the basic modules like crypto module, file system module, HTTP. There are some more, but these are the main ones. It's written in JavaScript. This JavaScript provides this API interface to the JavaScript code. The JavaScript doesn't have access to the operating system. It cannot access the network or it cannot access the files by default. But C++ has implementations to access the operating system. So what the core module do is it leverages the C++ functions to access the operating system, and it connects those functions to a JavaScript-based API to be consumed by the user's JavaScript code. So the node provides the secret sauce to convert the C++ access to the operating system, file I/O or network I/O, to be converted to JavaScript functions to be used by the user's JavaScript code. So our user can simply require the HTTP module and perform various HTTP functions. He could create a web server, he could listen on that port, and he could listen for those requests and execute some code based on those requests. So the third piece here is the libuv. So the libuv is also written in C++, which provides the basic TCP, UDP, and other operations, which is used by the C++ side of the code to talk to the operating system. So the C++ side of the Node Core module talks to the operating system through the libuv. So let's say it has to make a network I/O. The network I/O needs a TCP or a UDP connection, which is provided by this library to connect to the operating system. So Node uses the libuv to interact with the operating system for those requests. Libuv also provides the thread pool and an event queue for the I/O operations. So what is happening here overall? So the user uses the core module like an HTTP function to perform web services, and he writes all the code which is fed into the runtime. So the V8 engine takes all the JavaScript code, converts it into machine code, which is run by the operating system. So when an I/O request comes in, when like an HTTP request comes in, it goes through the V8 engine, and then the corresponding C++ implementation call is called in the C++ side of the Node Core modules, which activates which calls the libuv functions, which talks to the operating system for file access or network access. So the V8 runs this single-threaded event queue. When it receives a HTTP or any other request, it passes it on to the libuv for the I/O operation, and then it takes in the next request. When the request is complete, when the operating system provides a response, the libuv provides a callback for the request, and the data is eventually sent to the user. So this provides a basic node architecture. The piece I missed here in the explanation is the Express. So Express is a framework, a third-party framework which is downloaded via the Node Package Manager. So Express is downloaded by this npm, and then you could place the Express module inside your application. So the Express makes use of the HTTP Node Core module and makes those HTTP functions really easy. Express makes it super easy to create a web server, listen on a port, makes it super easy to create an API endpoint, create GET or POST requests. Okay, let's move on to the next slide. So here is a screenshot of the NodeJS project from GitHub. So here you'll see multiple folders. Some of the important folders are the deps, which is the dependencies, which has the V8 engine. It also has the libuv and some other dependencies. The lib folder, this has all the JavaScript code, which exposes the Node API for the core modules for the user's JavaScript code. So they could directly require these modules to be used for various functions like HTTP, file system, etc. So the source folder here contains all the C++ implementations which uses the libuv in the dependencies folder to talk to the operating system. So when you get time, feel free to jump into the GitHub page, have a look at the source code. You'll see both the JavaScript side and the C++ side of the node. Okay, next page is a screenshot of the Express repo. Here you'll see various JS files which will provide methods which uses the Node Core module HTTP and simplifies the HTTP functions for the user. So if you look at the application.js, it has various implementation to create the web application, other features regarding the request and response are on the corresponding folders. One example here is I want to show is the HTTP server. So to create an HTTP server, like a web server using Express, you technically write app.listen and then the port number. So by calling this app.listen, what the Express actually does is it uses the HTTP module and creates this server and passes on the arguments. So instead of writing code directly on the Node Core modules, you could leverage the Express functions, which makes it super easy to create a web server. And that's all I pretty much have for today. Node and Express is a very powerful combination, and it helps create super powerful web applications, which is super fast and efficient. And that is all I have, guys, for this video. I'll talk to you on the next one.